Hi dear students, today we are going to discuss work, power and energy important questions. One long answer question, one short answer question. So this is the 11th question, which is a short answer question, which already we made one video in Physicsframesgrb at important questions from past 20 years. So from that I'm picking one question, which is 11th question. Show that in the case of one-dimensional elastic collision, the relative velocity of approach of two colliding bodies before collision is equals to relative velocity of separation after collision. So this answer how you have to present in your board examinations. Now here when you see the diagram, first you have to draw the diagram. In this diagram, two bodies of masses m1 and m2, which is A and B. Initially they are moving with initial velocities u1 and u2. This is nothing but before collision. So during a collision, F1 is the force acting on second body and F2 is the force acting on first body. Then after collision, A body is moving with velocity v1 and B body is moving with velocity v2. That is after collision. So when you carefully observe, before collision initial velocities are u1, u2 and after collision velocities are v1, v2. Now consider two bodies A and B. So how to explain this one? That is the answer will start with explanation. Consider two bodies A and B of masses m1 and m2 respectively are moving along the same straight line in the same direction. Next, let u1, u2 be their velocities changes to. That means initial velocities are u1 and u2. They're changing to what? v1 and v2 respectively. And they move along the same straight line in the same direction. That means both should be before collision and after collision they should move in a straight direction, which is nothing but we also call it is one-dimensional collision. Next, see, applying law of conservation of linear momentum or total momentum before collision is equals to total momentum after collision. So momentum is nothing but product of mass and velocity, that is m1 u1 plus m2 u2. This is the momentum, total momentum of two bodies before collision should be equals to momentum after collision, that is v1 m1 v1 plus m2 v2. That is the total momentum after collision. Just rearranging the equation, m1 is taken common and u1 minus v1 is equals to m2 into v2 minus u2. Just we rearrange the equation. After as elastic collision, as it is an elastic, as a collision is elastic, the kinetic energy is conserved. So according to the definition of elastic collision, both kinetic energy and momentum is conserved. So kinetic energy before collision is equals to kinetic energy after collision. So one thing you remember that in elastic collision, not inelastic collision, in the elastic collision, kinetic energy and momentum both are conserved. So first conservation of linear momentum is completed and we wrote the equation for that one. Now kinetic energy before collision should be equals to kinetic energy after collision. So as the kinetic energy before collision is half m1 u1 square plus half m2 u2 square. This is nothing but total kinetic energy before collision of two bodies should be equals to half m1 v1 square plus half m2 v2 square. This is the total kinetic energy after collision. So first before collision total kinetic energy should be equals to total kinetic energy after collision. Now similarly half on both sides will get cancelled. m1 into u1 square minus v1 square is equals to m2 into v2 square minus v2 square minus u2 square. Here just we rearrange the equation. m1 is taken common and m2 is taken common. Now v1 square minus u1 square u1 square minus v1 square, which is nothing but a square minus b square form. So which can be written as a plus b into a minus b. That is m1 into u1 plus v1 into u1 minus v1, which is equals to m2 into v2 plus u2 into v2 minus u2. This is equation number 2. So already we got equation 1. Just you can verify it as m1, if you take it as common, u1 minus v1 is equals to m2 into v2 minus u2. This is the first equation. This will be the second equation. Now what we do is applying just dividing both the equation 1 and equation 2 is divided. Then m1 u1 minus v1 is get cancelled, and m2 v2 minus u2 will get cancelled. So what is the remaining thing? u1 plus v1 is equals to v2 minus, okay, so you can see here v2 v1 plus u1 plus v1 is equals to v2 plus u2, right? Now here you can see more clearly. So as we are dividing equation 2 by 1, we are getting u1 plus v1 is equals to v2 plus u2. So again rearranging the equation, u1 minus u2 equals to v2 minus v1. So that is equation 3. You can see now the relative velocity of approach before collision is equals to relative velocity of separation after collision. So this is the final answer. So this is the way that you have to present the answer with respect to the diagram.